Right now I'm going to go over how to graph and also analyze quadratic equations that are in vertex form. So what we're going to do first is look at this equation here. We have this function of g of x is equal to x squared minus 5. We know that our formula for vertex form is a times the quantity of x minus h all squared plus k. So if I want, I can rewrite this original equation that we're given. And we know a, there's no number in front, so the identity of multiplication is just 1. Times x minus, there's no number written for h, so we know the identity for addition and subtraction is just going to be 0. So my h value is 0 for my vertex. And then out in the back, the constant behind it by itself is negative 5. So when x is 0, we have a negative 5 as our y value. So our vertex is going to be negative 5, or 0, negative 5. So if I want, I can graph that point. I'm going to go to 0, down to negative 5 on my y-axis, and that is the vertex of my quadratic. Now we notice that a is positive 1 over 1, so I can graph a point to the right and left using this factor of my vertex, but only 1 point to each side. Since this is a quadratic, both of my legs are going to be exponential, so I can't use this factor for every point of my legs, just the first one. So I can go for my origin, at my vertex, I go up 1, right 1, and I can go back to the vertex, up 1, left 1. So if I wanted to say 1, if we did it the long way, we could do 1 squared, which is 1, and 1 minus 5 is negative 4. So if I double check that point, I go right 1 and down 4, and look, that point right there is 1, negative 4. So it works out either method. After you do that, we need to remember our axis of symmetry is going through our vertex. It's a vertical reflection line that we can't see. So what we need to do is make sure we have enough points so that we are able to figure out what our shape of our quadratic looks like. So what I'm going to do is choose another point. So we just did the vertex and we did 1, and I'm going to do 2 now. So I'm going to plug in 2 for my equation. So 2 goes in for x, so it's 2 squared, which equals 4. And 4 minus 5 is equal to negative 1. So I'm going to go right to 2, and I'm going to go down to 1. Now, I can graph my reflection point, so I'm going to go, I notice it's 2 places away from my axis of symmetry, so go 2 in the opposite direction, and I can graph that point. Now you do have enough points to figure out what the shape looks like. However, what I'm going to do is I'm going to do another point for the fact that my graph has not crossed the x-axis yet. And since I know it's going up, I can see that it's going to. So I'm going to plug 3 in. So 3 squared, we know is 9. And 9 minus 5 is 4. So we know that point is 3, 4. So I'm going to plot that point. I'm going to go right 3 and up 4. And now I have a much better illustration of what my quadratic is going to look like. I see it's 3 places away from my axis of symmetry. So I'm going to go 3 in the left, the opposite direction. And now that I have enough points, I'm going to connect my points to make my quadratic, and it is going to be a U shape. And that's it. So if we quickly look at these 2 illustrations, we just graphed a function that looked very similar to this picture on the left. We see that it's a positive function, meaning it's going up. So our vertex is going to be considered the lowest point of this function. And since it's the lowest, it's considered the minimum value. And that minimum value in terms of the y-axis is going to be y is equal to 0. That is the smallest y value that this function in this example can be. If we look at the opposite one over here, we see that our vertex is the biggest point. It's our highest point, which means we have a negative function because it's going down. And that means that our highest point here would be y is equal to 0 as well for the maximum value. So our range for these would be, the second one here, this range would be y is less than or equal to 0 because 0 is my highest point and it's going down to anything smaller than that. And on the first one, our range would be y is greater than or equal to 0 because 0 is the smallest value and it's going up to every number that is bigger. Now what we want to look at is looking at this a function that's a quadratic in vertex form and be able to interpret what it is. So we see here, looking at this equation, that we have y equals 3 times x minus 4 all squared minus 2. So we know, looking at this, our vertex is whatever hk is. So we know it's a times x minus h squared plus k. So our h value is whatever's written behind the minus sign. So it's the opposite of the minus. So that makes our h positive 4. And since there's a plus sign in the formula, that means that negative sign is part of our vertex. So it's negative 2 for my k. So my vertex is 4, negative 2. Remember, our axis of symmetry is that imaginary vertical line that's going through the vertex. So if my vertex was at 4, negative 2, then my axis of symmetry is a vertical line where my x is positive 4. So we have x is 4, which is our axis of symmetry. Whatever your h is, that is what your axis of symmetry is. Now, looking at determining if it's a maximum or minimum, we need to figure out what a is. If I look at this, we know a is positive 3. Since it is positive, I know my function is going to go up. Since it's going up, I have to look at my vertex and figure out, is that the lowest or the highest point of my function? So looking at this u, I see that my vertex is at the bottom of the u. So it is the lowest point. So it is the smallest point or the lowest point of my function. So looking at this, we know it's the lowest, so it's the minimum value. And that minimum value is, in terms, we talk about y. So y is equal to negative 2. And finally, we're going to determine our domain and range. Since our quadratic is going up and down, it is going to be all real for our domain. No matter what x or y value, this function is going forever and ever up to the left and up to the right. Now our range is going to be a little bit different because we notice our u stops at the vertex when y is negative 2. Our smallest y value is negative 2. So that's going to be my bound. And it's going up. So every other number is greater than, but it also can be equal to negative 2. The other way you can write it is you start at negative 2, which would be a closed bracket, and you're going forever up to positive infinity, which would be a parenthesis since it goes on forever. And that is how you interpret a quadratic function that is in vertex form without graphing.